like this group feature. No, not yet, I think. Like this Control G. No, but.
But the equivalent would just be a new patch, right?
Yes, you would.
There's Control Shift P, which will create a new, but then you have to copy the stuff too.
Yes.
And it will not create anything.
So if I, for example, want to make a node here, then I can press Control Shift P, will create a node, created a new patch, so to say, and I would have to cut this stuff, go in there, paste it again, and put out the connections. So the whole.
For example, the behaviors you could put in there, like behavior factory or something like that.
And if you create a new patch with Control P, you're creating it stateful or stateless?
It's a stateful.
Yeah, you can check it in the document patch. If you
Yeah,
have
if you
the
go up.
document patch to see, this is patch.
Yeah, stateless would look like this. You type in here operation, for example. You define an operation, yeah, foo bar operation, whatever. And now you could start patching here. You could think of that these are rendered the same way that I, for example, here the agent, that the agent gets, you know, all the stuff we see here, it gets rendered right here. Would also be a possibility. We simply decided that it's usually it gets a lot of stuff in here, so we just hide it here. But this is, so to say, a stateful patch, and this is just a stateless patch. This is just a function. This is more. This is a type with a lot of functions and fields and stuff.
And the stateless patch only has it's basically a function, right? So
it's just a
like
function.
A stateful patch which has like this different operation.
Yeah.
Now it's basically constructed.
Yeah. If I don't know if I'm not sure what happens now. If it will allow me to do that. If I paste this stuff in here, I get a couple of errors. Okay, he will say here, the process can only be used in a stateful patch, for example. Here again, the field needs a stateful patch, so it doesn't allow that. But, maybe the question why stateful, stateless? Well, one reason is that when you have a stateless node defined, then you know that the output is only dependent on the input. There's no kind of memory going on. So in case you are looking for errors or some kind of misbehavior in your patch, it's sometimes easy if you know, okay, this can't be the thing. It has to be there, the problem. So it's one of the reasons why we kind of expose both kind of patching styles.
Would be as well. Maybe first, congratulations on what you achieved already. I think it's a lot.
Yeah, thanks.
Impressive. What the future? Are you intending kind of to replace them before this out at a certain point, or?
Yeah, but only when we're really satisfied that you can really do the same things what you can do in VVV now. So it can take quite a while still.
And second question is more general question, because I'm generally interested in this kind of visual programming environments. How, I don't know, what is this kind of extra thinking which you have to do to kind of translate these programming concepts to this visual part, or how are your workflows in general or how do you come up with ideas to kind of prototype a visual language in general?
Yeah, well, it's lots of trial and error. It was. I mean, we started with this whole thing. Was this kickoff we called it, where we just did some brainstorming? It was 2010, something.
9 or
10, I think. This was just brainstorming and like what we wanna have in there, what we all miss in VVV, First thing was like a real type checks, a real typing system. Like what you see all the time, he infers all the types and everything. And we put a lot of ideas in there and kind of built some kind of prototype. And then we stopped working on it for a year or something, or 2 years even. And at some point picked it up again. And then it's a lot of iterations, basically, where you try stuff and then you see.
For example, the pads, they look totally different in the beginning. And loops also look different. And I think loops had like 2 iterations until they arrived to the state they are now. And pads also had 1 iteration. So we said, okay, it's not really practical to use it. But now with the loops, we are kind of satisfied that it's like you can do whatever you want and you can do it quickly.
Has anybody of you already checked if this all compilers on Mono, Linux, or
we are waiting basically for the core CLR on this part. So .NET bought Mono, Microsoft, they kind of merged together, and now it's called core CLR, the whole thing, and it already runs on, I think, all platforms. But it misses the whole WinForms and WPF stuff. I'm not sure what the direction is in these regards, but basically we're waiting on this. So I'm sure that the compiler here will work on the core CLR. But for example, the framework would not, or if you would patch something with graphic stuff in there, it wouldn't run on the core CLR anymore. So this is kind of dependent on Microsoft, what their direction is and what they are going to do. But I'm confident that it will work later on.
fingers crossed?
I would like to know, like I only use it for Steam projects now, before program, but if I use it like to earn some money with it, and when is there a point where you have to pay for the program? Is there a point? Or
so the question is about licensing. Are you? Yeah, currently it's the same as it's when you earn significant money, when all your income depends on your daily work with VV, then you need to buy a license. And as a student, you don't.
Okay. When is there the point? Like
this is up to you. We trust you that you will know the point when it's the correct time to buy a license.
I think the zooming is also great for nervous people that you have a zoom. Makes a lot of.
Yeah, but to your question again, like how did we start it or how did we develop it? It was also clear, and this is what you still see right now, and I think it's important to know that we aimed for a kind of a low-level language, so that the first thing should be kind of low-level, and get higher-level stuff later.
On top of it.
On top of it, like spreading in VVVV, like you can just have a plus node and then put the spread in there, for example, and it does this looping inside, or I don't know, that it remembers values and just does the execution when it changed. All this kind of stuff which makes patching easier and more comfortable was something we decided to put on into a second iteration later on.
So it's still plan to do some higher order nodes, well not higher order, but more abstract nodes that bring like the spreading behavior.
Yeah, I mean this is something we have to put into the system more or less. I'm not sure if you can achieve it with the delegate approach, for example, because it's too fixed. You need to have more, I don't know, support by the system to know what's going on. Yeah, but there are a few ideas, nice ideas, which will get, I don't know, out there when we have time for it. Because right now, like we said in the blog post, we're just right now concentrating on the importing stuff. So how do you import stuff directly from .NET? So that people can write libraries and extend the whole system like it is now. We thought this is very important to get this out as early as possible so that people can build up libraries like a graphics engine or stuff like that. And then we can in parallel kind of go back to language features and these kind of higher level concepts I just
I think this is also an interesting point that for example here in the agent, this node here is imported from sharpdx, and this is not some kind of wrapper or so. This is just the original code that was compiled by the library developer of sharpdx. So it's directly linking into this this library. So there's no extra effort you have to do to write nodes for VL. You don't have to write them in any special way. You just write a C# method if you want to create C# VL nodes in C#. Just write a method, or you just write an operation there, and VL can just use it as a node. There's no special API or so that you have to take care of. It's just native .NET code that you call here.
How do you get it inside?
This is what we're basically working on right now. There is a system, but we didn't want to make it public yet, because there's some workflows we know that they are kind of flawed, and we're working on that. And hope is April or something, new version where this whole thing gets documented and then explained, and so the library can be built up by other people. Yeah.
But the simplest idea is you compile something in C# or with any .NET language. You compile it, then you get a DLL. Then you reference the DLL in your document. Up here, there's a dependency dialog here. Then here you add something, and it will just check what is there. All the public methods will then be available as nodes.
A lot of people ask about the asynchronous operation. Is it meant to be, or will it be possible to use it, for example, for a user interface? Because now, whenever you, for example, move email, the rendering pauses.
Yeah, but this has nothing to do with this thing, because there's a strict separation between the whole development environment, so to say, this whole patch editor, and the target code which gets so your program which gets executed. So usually there's a strict separation there, but since we are in VVVV itself, we are kind of bound to this main loop of VVVV, and the main loop of VVVV runs in the main thread of the process,
and the UI as well.
And so what we should do is to separate the main loop of VVVV with the UI thread. If this would be done in a very general way, then there would be no such thing that when you move the node around that the rendering stops. So this is kind of a limitation by VVVV right now. In the standalone version of VL, we have of course a standalone where I just have an X and start VL directly. There it's already possible to start the program on a different thread, and then it doesn't compete with the whole patch editor. So I mean, this is kind of an old wish for VVVV that the main loop gets separated from the editor. But no promises there.